Good evening and namaskar to all the educators. My name is Amit Bajaj and I'm the founder and leader of Google Educator Group GEG Delhi West.
I am
Very
Nidhi
well.
Bhadra, co-leader of GEG Delhi West.
Good evening, everyone. Myself, Meena Bagga, co-leader GEG Delhi West.
GEG Delhi West is committed to learn, share, inspire, and empower all the educators. Today we have a session on the topic Basics of GeoGebra for Teaching and Learning Mathematics by Mr. Kaushal Sen. In this session, he will introduce us to GeoGebra, which is an interactive geometry, algebra, statistics, and calculus application intended for learning and teaching mathematics from primary school to the university level. Today, he will be sharing with us his expertise in GeoGebra, which is incredibly valuable for anyone looking to learn, improve, and expand their understanding of GeoGebra. Please feel free to ask questions or make comments as we go along. We are here to learn and engage with each other. Let me now request Nidhi ma'am and Meena ma'am to share a brief profile of our session expert, Mr. Kaushal Sen. Welcome, sir.
Welcome, Kaushal sir. Kaushal sir is a mathematics educator from Presentation Convent Senior Secondary School, New Delhi. He is also a Google certified educator and Adobe Creative Educator. He is working with NCRT, DIET, and different organizations like Teacher Helps Teacher and Teacher Class. He is very passionate to give the experiential learning to students for different tech tools. Welcome, sir. We welcome you. Nidhi ma'am, over to you.
GeoGebra helps students to visualize mathematical concepts that can seem abstract at times. It is a useful application to improve and enrich mathematics, teaching and learning, which is extremely useful at all levels, right from elementary school to university. So we heartily welcome you, Kaushal sir. We are all ears and will be backstage. You can call us anytime, we'll be there. And we are so excited for today's session and learn how GeoGebra empowers teachers and learners of mathematics. Over to you, Kaushal sir.
Thank you so much, Amit sir, Meena ma'am, and Nidhi ma'am for this hearty welcome. And my dear participants who have joined me, thank you so much for taking out time to join us with this GEG Delhi West session. So today we will be talking about the basics of GeoGebra. And as I know that Amit sir is also a mathematics teacher, and we share a co-passion of bringing beautiful tools into the classroom for our senior students or for our primary or middle school students. As sir said, that this can be used in the primary classes, in the middle school classes, and it can be taken into the university level also. So without wasting much time, let us now move to the application GeoGebra. So when we go to this Google, Amit sir, do let me know, is my screen visible or not?
You need to share it, sir. Yeah, I will bring it. Yes, it's coming. So, sir, will be at the backstage.
So yes.
Call us. Yeah, thank you. Please carry on.
Sure, sir, sure. So this is the website geogebra.org, and this is a beautiful world where educators like us can bring beautiful things on the screen and help our students visualize the concepts of triangles, quadrilaterals, graphs, and some different topic. So when we come to this application GeoGebra, on the left hand side we have certain tabs. The first tab being the home tab, where we can start the calculator, and then we can start with the basic things. So if I open the calculator opens up, the calculator suits open up, and then some graphs can be done. There are certain tools that are there, like you can see the move tool there, intersection tool is there, object tool is there, media tool is there. Then we have the table tool, which help us provide a table, and then we also have the algebra tool, which helps you, gives the view of the particular interface. Let's come back to the original part. Then we have the news feeds. Now there are a lot of educators who use GeoGebra in a different manner. Then all those articles, blogs comes under the news feed part. Then we have the resources which educators like you develop create and share with the community to make it more useful for our student. Then if you want to create your individual profile where you want to save your own material and your own activities for your students, then you can definitely go to the profile part and you can sign with either Google, Facebook, or you can sign with any email ID that you wish to. Then you create your password and then sign in. So all your work that you are creating for your students or for your own self will always be saved or will remain in your profile. Then the next part is the people part, where different educators are there, different creators are there, where you can follow them and then can understand their pedagogy, understand their way of taking GeoGebra into the classroom and getting inspiration from them and taking it back into the classroom. Then we have the classrooms area where we can have live conversations with our students, so we can have a code and then we can join that particular part. And last, we have the app downloads. So GeoGebra is available both online and offline. It is the most beautiful thing that a particular tool can have, that it is available online and offline both. So for today's session, I am using the Classic 5, GeoGebra Classic 5 version I am using. Then if you see on the screen, we have the GeoGebra Classic 6, we have the CAS calculator, 3D calculator, geometry, graphing calculator, and calculator suite. So these are the different variations of GeoGebra apps that we have. So according to your own need, you can download that part and then can make your classrooms more fun-filled and more engaging. So for today's session, I am using the GeoGebra Classic 5, which includes free tools for geometry, spreadsheet, probability, and CAS. So you can explore on your own which tool or which app is suitable for your classroom or for your own studying and then can take it up. So without wasting much of time, let us move to the interface of GeoGebra Classic 5. I'll minimize my screen, and here is the GeoGebra Classic 5 interface. So the moment I open it up, if you observe carefully, we have two views open on our screen. The first view is the algebra view, where we get the equations, the distance, the heights, the lengths that we put on the graphics view. Suppose if I put a point, this particular point. So the moment I put this particular point, you will see on the algebra view, we are getting the coordinates of point A, the first being the x coordinate and the second being the y coordinate. Similarly, if I put a point B here, then again in the algebra view, I am getting the coordinates of point B. So we have two views here, algebra view, which is going to help you with the numbers that we are plotting on the graphics view. Now I'm going to click on Control A and will delete my entire thing that I have done. Let us come and explore the various options that we have here. The first is the move tool. The move tool is a very important aspect of this particular GeoGebra Classic 5. It helps you move your diagrams, it helps you move your graphs, and then there is a slider which we are going to see that is going to take place with the help of the move tool. So as you see the move tool, you can drag or select objects. Then we have the next part, we have the point tool. Under the point tool, we have a lot of options. The first being point, the second being point on object. Then we have attach, detach point, intersect point, midpoint or center, complex number, turning point, and roots. So in the second part, we have the points part. Let's come to the third part. I would like to make a mention here that when we are selecting a particular box, the box will transform into a blue color boundary part. If you see, so currently I have selected the point tool. So if you see, the point box is completely bounded with the blue column, and the remaining, if they are not highlighted, that means they are not selected. Suppose I select the circle part. So the moment I select the circle part, the square will transform into a blue color perimeter. The third thing that we have is the line tool, which gives me different kinds of lines like line, line segment, segment with a given length, ray, polyline, vector, vector for point. Then the fourth part is the types of lines that we have studied: perpendicular, parallel, bisector, angle bisector, tangents, polar or diameter line, best fit line, and locus. Then we have the polygon part. The most interesting aspect that we will do today is the angle sum property of triangle, and we are going to use the polygon part. So please keep your seat belts tight as we dive deep into this GeoGebra app. Then the fifth, we have the circle part where we have these options like compass, circle through T points, semicircle, circular arc, circular sector, circular sector. Then we have the ellipse part, which we can use in classes 10th, 11th, and then in 12th. So in class 10th, if you want to make our students a little go higher than their syllabus, then we can use the ellipse part, hyperbola, parabola part. Then we have the angle part where we have angles with given size, distance, area, slope, relations, function inspector. Then the third last we have the reflections part. We can reflect a particular polygon around a line. We can reflect it around a point. We can reflect it around circle. We can rotate things. We can translate by vector and we can enlarge from point. And then we have a slider. Then certain options are there like text, image, button, checkbox, input. These options are available. So if you want to give a text, if we want to create an image, or if we want to put up an image, those we can do. And then we have the zoom out, zoom in, move graphics view. So if I click on the move graphics view, so I am moving the graphics view like this. So if you see, if I only want the positive x and the positive y axis, so I have moved my interface, and here I am having only the positive x and the positive y. If I want to slide it up where I want to see all the four parts, all the four quadrants, then I can use the drag tool to drag my interface. Then I have the zoom in, zoom out. So if your students want to see a particular image, or if they want to understand a particular concept, the dimensions, the constants that are there, the variables that are there, so then they can use the zoom in and zoom out part. Then we have the delete option, then the show or hide object, and the copy visual side. So these are some of the tools that we have on the GeoGebra classic file. Similarly, on the other applications also, you will have certain tools which will help you make the use of this particular tool. So let's begin with our today's session, where we are going to learn the concept of parallel lines and the angles which are made by the parallel lines. This is a concept that we learn in class 7, where we teach the students the concept of corresponding, alternate interior angles, and co-interior angles. So let's begin. So I would
Sir,
like all of you.
sir, sorry to interrupt in between. One of the educator is asking that how to go with this screen. So I think he's not able to go with this starting. Can you quickly tell that how to get this graphical view on the screen?
Uh, uh, so, uh,
How to start with
Dear
the GeoGebra?
educator, who said, yeah, you directly start with the GeoGebra. So if I come to, once you have downloaded that part, the icon will come. You install that part. After the installation is done, you click on the GeoGebra icon, and the moment you click on the GeoGebra, it will give you the algebra and the graphics view. The graphics view is always available with the classic 5 app option. And dear educator, if that is not available, then you go to the home part, you go to the start calculator part, and there you have the this algebra view. So if you are
Yes.
unable to download it and do it, so then you can go to the online part, go to the calculator suite, and then you can begin with the thing. So let's come back. Yeah.
Yeah.
So dear educators, tell me, as I was explaining all the tools that we have on GeoGebra Classic 5, tell me, which tool should we use to create the parallel lines part? Is it the third icon, or the second icon, or the fourth icon? So you have three options with you: third, second, or fourth. Yes, I know all of you must be thinking that this is the second icon that we will be using. No, That's incorrect. The fourth icon we are going to use where we have the parallel lines B. So how are we going to start? So before we start, we are going to select the point tool. So let's begin, and if you want to make some notes, you can make up those notes, or you can definitely come back to and watch the video once again. So to create parallel line, we are going to first create a line, and a line will have 2 points which are going endlessly in both the directions. So let us come to the point part, and here I'm going to click on the point part, or rather what we can do, you can use the line part. We are going to click on line. We will click 1 point, second point, and here we have a line with point A and point B. You can use the points also and then can join them, or what we can do, we can use the line part. We have clicked on 2 points, point A and point B, and then we are getting a line. Next, we want a parallel line. So what we shall do, we will now go to the fourth option. We will click on parallel line. Then we will click on 1 point either above AB or below AB, whatsoever you want like. So I am doing below AB. I am getting a point C, and then I am going to click on the line AB. So you see I am clicking on line AB. The moment I click on go to line AB, a plus but this hand symbol is coming. I'm going to click on this, and here we have a line parallel to AB. So what we did, we went to the line tool, we clicked on 2 points on the graphics view, we got a line, then we went to the parallel line tool, we clicked on a point. You can click it either below or either above. You click on a point and then click on the line. Now there's something very interesting that we can see here. We have got 3 points, and as you can see in the algebra view, we have the equations also. So this F and G that we have, these are the equations of the line, and the A, B and C part, these are the coordinates that are there. Now if you observe, we have the points in blue color. If I go to the move tool and take any point, take a look. The moment I am taking point A up and down, the line C, the line segment, the line with point C is also moving up and down. So this is how we can teach our student that no matter what, the parallel lines are never going to intersect. No matter what the distance is between them, no matter how much far they are, no matter whatever is there, the condition, the parallel lines will never intersect each other. Now, let's understand how are we going to teach the concepts of corresponding angles, alternate interior and co-interior angle. For this, we need a transversal, isn't it? So we are again going to the line part, and we will click on line, and then we will click a point above AB and 1 point below the line with point C. So now you see I have got a transversal with point D and point E, and the line is H. So we have got two lines, line F, line G, and H is the transversal which is going on. Now what do we need? We need the intersecting points of these there, after which we are going to find out the angle. So let us go to the point part where we are going to click on the intersect tool, because we want the intersecting point. So we are clicking on the intersect tool, and after clicking on this, we are going to click on the intersect point. So we have got point F, and then we have got point G. So these are the two intersecting points. Observe carefully that the point F and G have come in gray color. That means these are dependent points, and the points that are there in blue color, those are independent points. So let us take a look at the move part. The moment I rotate D, you will see D is getting rotated, but F and G, they are not. They are just sliding up and sliding right and left. Similarly, if I take point C, so point G is constantly there. It is going up and down. So that is how we are showing that these are dependent variable. So the moment I take point C, point G is also going. So that means now if I try to move point G, see, point G is not moving. That means that's a dependent variable on point C. So the moment you move point C, it is going to move up and down. Same goes for point B. So if I move point B, point F is moving. So this is how we can teach our students that the intersection points will remain there at that place. Now, our next part is finding out the angles. So let's come to the angles part. So we are clicking on the angles part. Now, in class 6 and in class 5, we teach our students how to name the angles. So to name an angle, we require three alphabets. So the same concept will apply here. We are first going to find angle B, F, and D. So this is our first angle. And then let's come to our next part. Let's do it A, F, and G. So this we are getting vertically opposite angles, isn't it? We are getting vertically opposite angle. Now if I want another angle, like let's take up the corresponding part. We'll go to the angles part. Yeah. So here I have three angles, alpha, beta, and gamma. So if you observe the algebra view, you will find out that beta and gamma, these are two corresponding angles who have the same value. Also, if we observe alpha and beta, they are also having the same value because they are vertically opposite angle. So now let us come to the move tool and find out if the parallel lines change their positions, if they go up, if they go down, are the corresponding angles going to remain same? Let's check it using the move tool. So now I am using the move tool and just dragging point A. The moment I drag point A, tada! There is no change in the angles. Alpha, beta, and gamma, they all are having the same values. That means the alternate exterior angle, alpha and gamma, the corresponding angle, beta and gamma, and the vertically opposite angles, alpha and beta, they are all same. So this is how we can present a visual proof to our student that when two parallel lines are intersected by a transversal, then the three types of angles that we talk, corresponding, alternate, and co-interior angles, they will always have these dimensions. The corresponding and alternate will be always equal, and the co-interior angles will always turn out to be some as supplementary angle. So I hope you all have understood the concept of parallel lines and how we can take the visual proof to our classrooms. Now, dear educator, if you want to save this activity, so what we can do, we can go to the file part and then we can click on either if we want an image that we can represent to our students for a particular example or for a question, then we can export it as a HTML or a PNG or a GIF part. And then if we want to save it as in our then we can click on the save as part and then we can get it. So my GeoGebra part is already there in my laptop. So I am going to write here PARA parallel lines, and then in my folder GeoGebra it is going to get saved. So here it is, I'm saving and my activity gets saved as parallel lines. So this is how when you go to your GeoGebra folder, your activity will always be there. You go, you change the dimensions, you change the things and take it to your students. So this is going to remain with you throughout. Now, after we have done the parallel lines, let's come to our next part where we are going to learn about angle sum property of a triangle. So again, I'm going to clear off my screen. Now, to create a triangle, we need the Polygon tool. Yes, absolutely right. You must be thinking that which tool we are going to use. So we will use the Polygon tool. Let's come to the Polygon tool where we are going to create a triangle. If you wish to use an equilateral triangle, then you can go to the regular polygon part. So like if you want a equilateral triangle, you can click on regular polygon. The moment you click on regular polygon, then you click on a particular point. Uh, the vertices is going to come. I'm going to write down 3 and then click on OK, and then here I have a equilateral triangle. But we will start with a random triangle. So I'm going to click on polygon. I'm going to take up 3 points, point A, point B, point C, and then back to point A. So here I have triangle ABC. The small letters A, B, C are the lengths of the sides of the triangle. So in the algebra view, you can see we have the length, and then the T1 that we see, that is the perimeter of the triangle that we have here. Now we are going to learn about how to prove the angle sum property of a triangle. Now for angle sum property, we again need the angles. So we are again going to go back to our angles tool. We are going to click on angle part, and then let's start finding out the angle. So first we are going to find out angle B, A, C. So I am getting the angle alpha. Then let's come to find out angle B, C, B, A, and then B, C, sorry, A, C, and B. So we have got 3 angles on the algebra view: alpha, beta, and gamma. Now, let us understand how we are going to show our students that the sum of all the 3 angles of a triangle is always 180 degree. So let us come to our input bar. So at the bottom of the interface, you will see this small rectangle tile in white color with input written on the left hand side. So we are going to the input part, and we will start clicking with uh, so input bar is there, and at the extreme right you will see alpha symbol is here. So click on that alpha symbol, and the moment you click on that alpha symbol, all the Greek letters are going to come up. So we will first click on alpha, then I am going to type plus, then again back to that alpha symbol, I'm going to click beta, then again plus, and then lastly we are going to click on gamma, and then we are going to click on enter. So the moment we click on enter, we are getting a 4th letter, and that is sigma, or let us rename it ASP of triangle. I am renaming it so I've got ASP. So yes, so the moment I have clicked on ASP, you will see that the sum is turning out to be 180 degree. This is so beautiful. Now let's come to the move tool, and let us make our students surprised that if we change the angles. Now this is an obtuse angle triangle. The moment we have an obtuse angle triangle, again the sum is 180 degree. Here the angle alpha and gamma, these are acute angles, whereas beta is 126.55. Then if I want something called 90 degree, slightly 90, so then again in a right angle triangle, again the sum turns out to be 180 degree. So you can take up any point and can drag it up and can show students that no matter what, no matter the length, no matter the angle that we have, the sum will always turn out to be 180 degree. This activity you can use for quadrilaterals also, and help students understand that in a quadrilateral the ASP is again 360 degree. So these are visual proofs which help a student understand that no matter what the triangle is, no matter what type of triangle is it either based on sides or based on angles, the sum will always turn out to be 180 degree. And when student sorry and when students explore with using the move tool, where they move the points A, points B and point C, they are able to visualize carefully and then analyze the concept in a better way. This activity you can take the lead by using the line segment tool. So if I want to teach the students, okay, sorry, just undo it. If I want to teach my students the concept of exterior angle property, then I can teach the concept of exterior angle. So here is my line.
Sir, if possible, can you go a little bit slower? Because one of the
Slower.
educator is asking
Okay.
this. A little bit, yeah, slower, if possible. Yeah,
Okay. Okay,
yeah.
sure,
Thank you.
sir, sure. So now we are taking up the exterior angle property of a triangle, which tells us that one exterior angle is always equal to two. The sum is always equals to two interior opposite angle. So what I did, I went to the line tool and clicked on point C, and then I got a line. Why? Because I want an extension of line segment BC. So I have got the extension of BC, and now I am going to find out the angle DC and A. So we are going to click on angle. Here we click angle, and then we click on these 3 points D, C and A. So we have got this angle sigma. Now let's again come back to the input bar and add up alpha and beta. So I am going to go to the input bar. I click the input bar, and then at the extreme right, a small alpha is written. We will again go back to that alpha button, click on alpha plus, then we'll click on beta, and then we are going to click on enter to get the result. So here we have, now if you observe, the angles are coming in the algebra 141.4 and 141.74 degree. So if we remove, so I can say that my extension was not absolutely correct, but when we do it carefully, the extensions will be perfect, and you are going to get the absolute result. So now I'm going to click on my move tool and see, is the angles changing or not. So my angles are not correct to the two decimal places, but if we take the decimal place, if we take it before the decimal place, you will see that it is coming out to be 139 degree and 139 degree. So this is how we can also teach our students the exterior angle property of a triangle, where one exterior angle is always equals to the sum of two interior opposite angle. So using the polygon tool, the line tool and the angle tool, we can create two beautiful proofs and can share with our student. And when they see these things in the classroom, they are more attracted to the world of mathematics, and it brings new avenues for them. So this was our part for triangle. And now let's come to the third segment of our session, where we are going to talk about the rotational symmetry, or rather the reflectional symmetry that we teach in classes 6th, 7th and 8th. So again, I'm going to clear off my screen. Now, if I want to reflect an object, so before that, I want to create an object. And how we can create an object? Either we can go to the polygon part and we can create polygons, or we can go to the point part, join them with the line segments, and then create our figure that we want to go about it. So I am going to the polygon part, and we'll quickly create a figure, something random. Uh, Hmm. So this is a 1, 2, 3, 4, 5. So this is a pentagon that I have created, and as you can see, this is not a regular pentagon. This is a normal pentagon that we have done. Now, if I want to teach my students the concept of reflection symmetry, that is the image that we have on one side and the image that is there on the other side, they will be exactly similar to each other. Like when we teach congruency, so we teach that the two triangles that are there, they are exactly photocopy of each other. So in layman terms, when we have to teach them, so these are photocopy or these are mirror images. But how to tell them in this application? So what we will do, we are now coming to the third last tool, that is reflect object in line. So I'm going to click on this tab, it will drop down, and then we will take the first part, reflect object inline. So by looking at the icons also, you can understand that what exactly the tool is going to do to you. So if you go to this part, so it is showing that the red and blue dot is there, so it is going to give you a figure which is absolutely reflection image of the other part. I'm going to click on this, it says reflect object in line. So that means we need a line where the object is going to be reflected. So either you can create a line segment and then reflect it, or you can use any of the line segment of the polygon that you have created. So I will be using the line segment from the polygon. So let's click on this. I'm going to click on the line. We will first click on the line, and then we are going to click on the polygon that we have created. So the moment I click on this line, you will see it is coming double shaded. And now we are going to click on the polygon part. So the moment we click on the polygon, we are going to get a separate image on the other side of the line segment A, E. Now, if you observe the pointers that we have on the other side, these are A dash, B dash, C dash, E dash, and A dash. So A dash A and E dash E, they coincide with each other. Now, let's add up a fun and an interesting thing here. So if I want my students to understand this reflectional symmetry, what we can do, we can go to the move tool and move the pointers. So as we are moving the pointers, the image on the other side is also moving, and it is coming absolutely same. It is coming absolutely like a mirror image. So they can, so if they have used a lot of pointers, so then they can click on any pointer, and then they can create some beautiful images. So see, something beautiful is getting created. And these days, under the national education policy, we have a lot of projects related to art integration, isn't it? So what we can do, we can ask our students to use this tool and create some beautiful sceneries or images, and then they can have some beautiful art. Now, if I want to change this dull color brown, what I will do, I am going to click on, I will right click, and then some at the base object properties will come. So I'm going to click on the object properties. The moment I click on the object properties, on the right hand side a panel will open. So now there are 5 things that are there. The first is basic, that is you can change the name. If you want to change the definition, you can change the definition. If you want to give a caption, you can give a caption. Then the interesting thing that I want to do is color part. So I'm going to go to the color part, and various colors are there. So let's choose this color. And if you want to increase the opacity, so you can increase the opacity and create some beautiful images. So let's keep it at 50. Then if we go to the style part, then if you want to increase the thickness of the line, so currently it is at 8. So the moment I am dragging the slider, the thickness of the line is also increasing. Then if we go to the opacity part of the line, so the moment I'm dragging, it is again increasing and decreasing according to the number. Something interesting, the line style. So there are different line styles are there. So if you want to teach the reflectional symmetry, so then you can use the dotted line so that the students understand that the image on one side is the main image and the image which is on the other side, that is the symmetrical image. That is why the dotted lines are there. Then some different lines are there, then some fillings is there. So if you want a chessboard filling, so you can get a chessboard filling. So it's completely and beautifully to be used in the art integration project. You create some beautiful objects and then play with all these things. So then we have the honeycombs, so these, it's very beautiful. So I am just going to the standard part. Then in the advanced part, then we have all these options where if I want to increase the red mesh part, then I can create some. Then in the green part, then if you observe the blue part, so if I want to increase it, so I can increase that part, and that way the things can go up. So these are the three things that I wanted all of you to know, the basic color and style part. And then when, if sir allows me to take up an advanced session on GeoGebra, then we will definitely go to the advanced and the scripting part. Today we are not taking those. So with these basic color and style part, you can make beautiful images and you can allow your students to explore it and create some beautiful rotational symmetry objects that are there. So this was something about the the reflectional symmetry that is there. So what we have done, we have got, let's do one again, once more time. We went to the polygon part, we created a polygon, and then we went to the reflect object in line part. So what we did, we went to that reflect object in line, we clicked on that particular line segment from which we wanted to reflect. Once we clicked on that line segment, we will click on the polygon and then the object will appear on the other side. Now, if I want to reflect object in a point, so let's go to this. We are going to click on this point and then we will click this polygon and let's now try to rotate it up. Mhm. We quickly create a polygon. Mhm. I think there's some error, that is this part. Sorry, dear educators, I think this part is not working on my side, but we'll definitely come back to this on the reflect object in a point part. Now, let's come to the next segment of our session, that is the nets of 3D figures. So now we are going to look how we can inform or help our students understand the area, the surface area, the lateral surface area of cuboids and cylinders. And I think it's very important for them to understand the concept of net. So what are we going to do now? We are going to close the algebra view, and then in the view option, we are going to come to the 3D graphics. So we went to the view part and we are going to now click on the 3D graphics tool. So the moment we go to the 3D graphics view, we are going to get the 3D view on my screen. Yes, so here you see we have now two options. The first is the graphics options and the second is the 3D graphics view. So using the mouse, you can bring it in the middle of the screen so that your students and you both are able to observe the screen very, very carefully about how it is getting changed. So now what we will do, let's create a regular polygon, that is a square. Let's create a square, and then we are going to create a cube and understand the lateral and total surface area of the cube part. So I'm going to click on regular polygon. So here is my first point, here is my second point, then I want 4 vertices. I'll click on OK, and here is a square that I have. I go to the move tool and bring my slider down. So I'm going to move my graphics part, and let's move this also. So here I have my square which is on the graphics view also, and my square which is on the 3D graphics also. Now, the moment I go to the 3D graphics view, just observe the slider above. The things have now transformed. Now we have some different tools. We have the point tool, line tool, perpendicular line, regular polygon, circle with axis through point. We have intersect two surfaces. We have plane through 3 point. We have the pyramid option, sphere, angle. We have reflect in plane. We have text and move graphics. So some of the new options which have come up the moment we clicked on the 3D graphics tool. Now I want this cube to be transformed into a cube. So how are we going to go about it? We will come to the pyramid option. Let's come to the pyramid option, and the moment we come to this pyramid option, we can see we have this extrude to prism option. So either we can come to this extrude to prism. The moment we click on this extrude to prism, we are going to get a uh, so after we click on extrude to prism, we are going to click the square on the 3D graphics view, and then we are going to give an altitude. So let's me give an altitude. I'm giving 4, and I'm going to click on enter. The moment I click on enter, yes, so now I am getting a cuboid. So this is a cuboid. So from a cube, what we have done, so I have just transformed the activity a little bit. So from a cube, we are now transforming this into a cuboid. Now a cuboid, it has 6 faces where the top and base is same, the right and left is same, and the front and left is same. Now the interesting part, we will again go to the prism part and then click on the net. So the moment I click on net, I am going to click on my figure which is there on the 3D graphics. I'll click on this net, and beautifully we are getting the net of the cuboid. If you observe on the screen, we are getting a slider. The moment I use the slider, see so beautifully in the 3D graphics view. Let's take up the 3D graphics view a little bit. So the moment we use the slider, you will see in a butterfly way it is coming up and down. So this is how we can tell our students that a net, how a net is being made, what are the things that are required, and how the area can be taken up. So let me take it in this format. We will go to the move tool, and we are going to rotate the 3D graphics view. Let's bring it closer. So yes, so you can move up and down. You can show your students that this is how the net looks like. Now, if you want to color coordinate it so that the students understand how the top base looks like, so we are going to click on the face of whose color we want to change. So suppose if I want to change this particular face, so I'm going to click on this. I'll go to the object properties, and then in the color part, I'm going to, let's give it a brown color, and let's give it the opacity this. Hmm. So here I have a different color here. So now you see, if you observe the screen very carefully, so it's a pink color, that is the original cuboid we have. Then we have given a different color to our face. Same way, if I want to go to this part, Let's go to the orange color. So we have now this orange color on the cuboid. So this way you can change the colors and you can make sure that the things are easily understood to our students.
Sir, please unmute yourself. I think you're on mute right now.
Hello, hello,
Yeah. You're
hello.
audible now. Please go ahead.
Okay. So
Yes.
this is how
Wonderful.
the net can be used to help our students understand the concepts of total surface area and lateral surface area. So I hope you all enjoyed the today's class, the basics of GeoGebra, where we learned the concept of parallel lines, the concept of angles that are made by transversal, then the angle sum property, exterior angle property. Then we also tried to learn our hand on the reflect object around a line. We were not able to do on a point part. I think I have forgotten that thing, but I'll definitely come back to you on my next session with this part. And lastly, we did something with nets, something an interesting object, something an interesting topic in geometry that we teach, the concept of surface area, the total and the lateral surface area. We can create different objects and we can create different things and can help our students understand those things. Students can take it up as projects and can understand how the area is developed, what are the things that are there. If the radius is doubled, then what will be the change in the area? If the height is doubled, then how much it will change? So all those things they can visualize on GeoGebra and can understand that yes, if things are getting in this manner, then the areas, the volumes will change in this particular manner. So now with this, I would like to go back to the website where we have the GeoGebra applet. So this is the GeoGebra applet. So on this, you can create small activities for your students and can share with your students. So on the applet part, you can create an activity and you can assign it to your students. So the moment you click on the assign part, either you can give it as a GeoGebra lesson, or if you have the integration with the Google Classroom, you can click on the Google Classroom part and then can share it with your students, where your students will love the app and will take the lead further. So with this, I would request Amit sir that if there are any questions and yeah, if any suggestions are there, we are most eager to hear those things and answer those things.
Sir, there are two queries. People want to know how to change the scale, x-axis and y-axis. How to
How to
change the
change
scale?
this
Scale, x-axis ratio y-axis.
scale, as in they want, ma'am, this a bigger version or a smaller version, ma'am?
What ratio, sir? If we are taking different scale on x-axis and y-axis, 2:1 or 1:2.
2 ratio 1, 1
So
ratio
maybe the
2.
gap of 5 units on x-axis and 10, 20, 30 on y-axis, something like that. Maybe asking. He might be
Sir,
asking us
just
this
right click
question.
on the graphics. Sir, just right click on the graphics
On the
and
axis part we have
yes,
here.
x-axis ratio y-axis. Just show it, sir. You have got it here. Yes,
Yes, ma'am.
this
Hmm.
one.
So on the graphics view, we have these ratios that are there. So suppose if I click 1 is to 20, so this way I'm going to get 1 is to 20 part. Or if I
So
want to
there
have
is,
it,
yeah, so we can change the scale also through
hmm,
this graphic. Can we change the scale
on the
of the graph?
graphics view.
Okay.
Yeah, so on the graphics view, we can change this. So by clicking on right click, so thank you, Nidhi ma'am, for this information. Sometimes you also forget certain things.
Sir, one
Yes.
more query is there for inserting image. Inserting image.
Inserting image. Okay, so ma'am, so in the edit part, we can insert image from file. So suppose Currently, okay, let's see. So this way, so if we have an image, so we can insert the image on the screen, and then this is the image of this. I think this is a 2020 image that is there. So we can go to the documents part or wherever the image is stored, and we can insert the image, and then can teach our students whatever we
That's
want to
nice,
teach
sir.
them.
Sir, there is one more query. Please clarify if move tool can be used after saving the file or exporting it.
Mm, So once we have saved it, suppose I'm saving this, ma'am, 2022. So it is saved. So now let's use the move tool. So yes, ma'am, the move tool can be used definitely.
Okay, great, great.
So move tool is basically, so whosoever has asked, dear teacher, the move tool is basically to move the graphics view. So you can move up, down, and if there are certain pointers that you want to move up and down, so that way you can use the move tool. So as the name goes, the move tool is to move the things.
Can we record our work of GeoGebra for sharing?
Pardon, sir?
Can we record our work of GeoGebra for sharing? So whatever work we are doing
I
as
think
maybe in the Google Classroom we are sharing or as an assignment we are sharing, so definitely it's maintain a proper record of it. This is what I think sir is asking.
I think, sir, we can view the graphics view as an animated GIF. So I think it will. So I have not used it, but then I assume that whatever work we have done, if we go to the animated GIF part, we can definitely take a look at it.
Okay, sir. And how to go to the applet part? Tarang
So
ma'am is asking.
on Google, so I went to Google, and then on Google I typed the GeoGebra applet, and then if I want to insert, if I want to use my own part, I'll go to my profile, and then in the profile part I'll go to GeoGebra applet, create an activity for my students, and assign it to my students.
Okay, thank you.
Thank you,
So
sir.
Nidhi ma'am and ma'am check करिए. Do you have any other comment, remark or anything which is not covered in our
I
Q&A session?
think we have already
All the
covered most
queries
of
are
the
covered.
queries, and the overflowing comments of appreciation is quite evident that
One
our
query,
viewers
one
have liked.
recent query is
Yes.
there, sir. How to embed a GeoGebra applet in any slide deck? Is it possible to add in slide deck?
Sir, you're on mute, I think. Kaushal sir, you're on mute.
Sir or ma'am, we can take it as an HTML, and then we can put it into our slide deck wherever we want to use it as a slide deck. Or if it is a particular image, like for an angle, for a triangle that we have made, so we can go to that picture part and then can put it into our slide deck that is there. Or we can or into our profiles where we are creating it, we can take out the link and then can use it into our slide deck.
I hope Kirti ma'am, you have got your answer. Thank you, sir.
So I'm just sharing the feedback form in the chat box. So all the participants are requested to kindly fill up this feedback form. And I'm sure you had a great learning experience.
Thank you so much, Kaushal sir, for a wonderful presentation.
Yes,
And
it's
you
really.
have so much to
Thank you so
share.
much.
And
Great
we
part.
have
That was
learned
really
a
wonderful.
lot, various tools,
Yeah,
move tool, graphic tool, polygon tool, and very clearly you
yeah,
explained the concept of parallel lines, angle sum property, exterior angle. And the best part was that 3D graphic view and how the net of a solid was, because it's
yeah.
very difficult to visualize that abstract concept of net when we draw it on the board. So it's very difficult to visualize, but very and art integration ideas also, because we teachers, as teachers, we struggle for art integration. projects, and it was wonderful. So thank you once again for sharing the insights, and I'm definitely going to watch this video again. I'm sure Amit sir and Meena ma'am also have
Yes, definitely.
so much to share with us.
And sir, I think you're not aware. We all three are actually mathematics teachers only, not only
Yes.
me. Meena ma'am and Nidhi ma'am. We all are math teachers
Okay.
only.
अच्छा
Yeah.
अच्छा, that's
We
great.
are,
So I think
yeah.
चार मैथ्स
And looking
टीचर्स की
forward
टोली
for
ने
this
आज
advanced
धमाल मचा दिया है.
Absolutely. तभी अमित सर
Absolutely.
स्टार्टिंग में लिखा था,
absolutely.
वेलकम टू द वर्ल्ड ऑफ मैथमेटिक्स, लेट्स जस्ट ड्वेल्व इनटू इट, बिकॉज आज प्योरली मैथमेटिक्स सेशन था हमारा, एंड इट वाज ग्रेट. इट वाज रियली रियली ग्रेट.
Yeah. But yes, definitely the time is limited and
Absolutely.
there's a lot to explore. So definitely we'll be having another session, the advanced part of the same, based on the request we are receiving for the from the educators. Maybe now after the exam, after a month or so. So we're looking forward to this.
Yes, yes,
Any
definitely.
last important comments on
Definitely.
this side,
So
Nidhi
thank
ma'am
you.
and Meena ma'am?
Thank you, Kaushal
Yeah,
So
sir.
before
Thank you,
Nidhi ma'am and
everyone.
Meena ma'am
Sir,
says,
we are
thank
already
you
getting
so
the
much,
request
GG
of
Delhi West.
yeah. Thank you so much. Thank you all the educators for joining us for today's
Thank you.
session. Yeah, ending the broadcast and signing off. Thank you. Namaskar.